in addition to the challenges that Josh and Annie discussed, I'm going to talk about one of the other ones for Percid aquaculture, focusing more so on walleye, but a lot of this applies to yellow perch aquaculture as well. And that's egg acquisition and developing a captive broodstock, which is critical for the future of Percid aquaculture. And while there's a ton to cover in this space on the broodstock side, and not a ton of time in this presentation, so I'll point everybody to the walleye culture guide that Emma has put together. I have a link to it at the end of the presentation where we go into all of this in a lot more detail with pictures and step-by-step guide that hopefully would be great for people who don't have that formal background or previous experience to guide them through Percid aquaculture. So just briefly, why do walleye aquaculture? Walleye do hold a ton of promise as an aquaculture species. They're regionally well known as a high value food fish, particularly in Minnesota and Wisconsin, where they're the most sought after fish species. And there is a pre-existing demand from the wild caught market, although most of that is being imported from Canada from commercial fisheries. And because of that, there's this great opportunity for domestically raised walleye and yellow perch to kind of fill that niche and provide a more local source of those fish. So walleye in particular have been an up-and-coming species, also yellow perch. I'm focusing on walleye here. There's been over 15 years of work on making walleye a viable aquaculture species, which seems like a long time, but when you're talking about species domestication, that's a really short time period. So we're still very early in this, and there's many quirks to work out. That being said, we've made pretty great strides in those 15 years to the point where there are private walleye and yellow perch aquaculture, and it is viable. We have a couple walleye producers that have started recently that are doing well already. So it's exciting to see this space grow. That said, there's still quite a few challenges with an early industry like this. And one of those challenges is egg acquisition. Egg acquisition is kind of the cornerstone of any aquaculture endeavor. If you're not able to get those gametes to hatch out, you're not going to have fish to be able to grow out to market size. So this is a really critical thing to pin down if you're going to start a walleye or yellow perch fish farm. And currently, the primary way for getting eggs for your aquaculture endeavor is relying heavily on gametes collected from wild fish by natural resources agencies. So currently, your best bet right now to get walleye eggs would be talking to the DNR or Fish and Wildlife Service and asking them to set aside some eggs when they're doing their typical spring spawning for conservation purposes. And this is really cool. It's a great endeavor to watch the natural resources agencies do this work. It's a big production. But on the aquaculture side, there's a lot of challenges that this brings for your facility. First, you're subject to weather conditions in collecting these gametes from wild fish. So if you get a really late ice out like we had the last few years, that can really jeopardize your ability to get gametes and really put your aquaculture endeavor off a whole year, which is not sustainable. One of the big ones is a biosecurity risk from bringing in eggs from wild fish that are exposed to pathogens and other issues, contaminants that you can't control. And then you're bringing that into your facility, which may cause issues. There's also the big one, you're relying on the availability of natural resources agency staff to collect eggs for private aquaculture. And really, that's not their mandate. So it really limits your ability to scale up as your aquaculture enterprise grows. And if there's changing mandates by these natural resources agencies, your supply of eggs might dry up. So how this works is natural resources agencies will collect wild fish that are spawning. They'll be able to pull those fish out, and they'll be freely giving eggs if they time it right and milt. They'll fertilize those eggs on site at the side of the river or lake, and then you'll bring them into your facility into a bell jar incubation system like Amy talked about, and ultimately raise them up to grow out in your facility. And that's where those biosecurity issues really become present. So because of all these challenges with using wild broodstock, it really provides an impetus for an alternative solution, and that being the development of a captive broodstock. And the workflow here is, instead of just constantly bringing in gametes from wild fish, you would set aside some of your grow out fish and dedicate them as broodstock. And you need to raise them to approximately 3 years plus to get them to be reproductively mature. But then once you have those fish set aside, every spring when they're ready to spawn, you can collect eggs from them. And you would use those eggs to hatch out in your bell jar systems, raise through the larviculture, and then hopefully in 3 years of grow out, you would have them to set aside as broodstock again. So it kind of closes that loop. You're not bringing in any wild fish or contaminants, but there's some additional challenges to this. So if you're going to be developing a captive broodstock, there's quite a few requirements. I mentioned you need approximately 3-year-old reproductively mature walleye, which can be a challenge. Importantly, you need a separate tank dedicated to that broodstock, so that takes production system space. You can't commingle with your grow out fish because there's going to be size differences. Really importantly, you need independent temperature and photo period control, and I'll discuss this a little bit more. And then, of course, you need space for a bell jar incubation system and a dedicated larval system, which you might already have if you're bringing in wild gametes anyways. But importantly, something that many people don't really factor in is the requirement for that independent temperature and photo period control. So walleye and other persids require really cold water temperatures in the winter to undergo adequate gonadal development. So you might need to provide a temperature regime similar to what's shown in this figure here, where in the fall, you start dropping your tank temperatures down to some cold water temperature that simulates a winter period, and hold them at that temperature for some time before you warm them up to spawn. So as I mentioned, walleye in particular need very cold temperatures, otherwise they won't spawn. Generally, it's suggested that those temperatures be below 10 degrees, but the colder the better, largely for walleye and other persids. And then if you're able to do that, then you have some control of the process, because when you warm them up is going to trigger when that reproduction occurs. So spawning will generally take place after they've been warmed up from that cold period to temperatures of about 12 to 15 degrees Celsius. So you can kind of, to some extent, play with when that timing of spawning occurs. Additionally, you can administer hormonal injections to try to synchronize the spawning effort by your broodstock, and try to get them to spawn at the same time or have a better spawn. And that's a pretty common technique with persids. So the workflow might look something like this. As your broodstock fish are warmed up, you're going to be checking them fairly regularly. And you'll know when those females are starting to spawn. They'll get quite large visually, and when you lift them up, they'll be giving eggs freely. And that's when it's go time. So you'll strip those eggs in milt. Generally, you'll strip the milt right on top of the eggs and mix them before adding clay to prevent clumping, water harden for about an hour, and then disinfecting those eggs to prevent any contaminants. Even though they're inside your system and shouldn't be contaminated, it's always good to have that backup practice. And then they'll go into your bell jar incubation system that Amy talked about to hatch out. Ours at NADF looks something like this. We have our bell jars here. As they hatch, they swim out, and they end up in these tanks without us having to touch them at all or handle them. And then from these tanks, we can stock them into larval systems. So there's a lot that goes into developing a persid broodstock that should be considered, and a lot of pros and cons. But it's really critical to have a persid broodstock for the future of persid aquaculture. So some of the pros here, better biosecurity, you have more control over the timing of spawning and when you're going to be putting that effort in. You're not relying on the weather or a bad year that could tank your entire operation. You don't have to rely on the DNR or Fish and Wildlife Service, who may have shifting priorities. And you're not competing with wild fish fisheries, where there might be some sort of social license issues where recreational anglers think that you're taking eggs from their stocking efforts to stock walleye in their lake. But there's some challenges to this too. So the cons of developing a captive broodstock is that you have to have additional system space separate from your grow out. So you're kind of taking space away from your grow out production system. There's going to be additional energy costs as you have to cool that water temperature down in the winter, separately from your grow out fish that are going to be staying at warm temperatures. And then there's a 3-year lead time to get those fish to reproductive maturity. We're still early on in our understanding of broodstock requirements. So there's still a little bit of uncertainty in this process that adds some additional risk. So like I said, we've done a lot of work on the broodstock side and through all parts of walleye culture. So I really encourage folks to look at our walleye culture guide, where we have a step-by-step guide with a lot of pictures on how to do this, and that can be found at our website here. So that'll be the end of my presentation. Thanks.